floor. But I want to say that this morning we discussed that actually we're creating space, and obviously we're creating space on Mars, and well, also we are there. So, do you want to react to each other's presentation first, or did we ask a question first?
I can say something. Well, I was very glad that you you were talking before me, because there was I was wondering whether I should include some more background information, because it could make of course the film isn't really going into these really fascinating details about the work itself so much, but one thing I was wondering about when you mentioned that you're studying the organic compounds on Mars, that the bio what does she call herself, astrobiologist, she calls herself. She says, I mean, it's kind of known that Curiosity have found some of these clay in some clay kind of compounds. So can you maybe? It would be interesting
I'm not
to hear.
Astrobiologist, but anyway, yes, I think it's clear that Curiosity found some organic molecule. This is true, but they don't have the Curiosity doesn't have the capacity to know whether it comes from life or not. If they are biomolecule or just geological molecule. So the question is still there, but without any organic molecule, anyway, for us, there is no life possible. So these are bricks, but to know whether they come from a living kind of being, you need to go in further detail, which is not possible on Curiosity, neither on Perseverance. And Perseverance will send back samples that are collected to Earth for throughout analysis, while ExoMars will study them on Mars.
Okay, well, that clarifies it for me. I wasn't sure, It's like
yeah. Okay.
Actually, Dawn was talking about that, how it's. Well, she was talking, and maybe you could say something about this also. That there is also a huge difference between doing field work as a geologist in the field, rather than because also it's a huge difference what the rovers can do at the moment, because if you compare what you could do in the lab, if you could actually get it back. So is that something you've been?
What is interesting as a geologists walk, they look at things, they try to understand the context, and most of the time they would collect samples that are going to be analyzed in lab, or they look at it and understand what kind of mineral it is. But most of the times I would like to use the shovel or whatever they have to dig and understand what is beneath, to get the full context of where they collected the sample. And what is nice on ExoMars is that we have a view of what is beneath the surface. So it is fully complementary. I really enjoy the fact that you said, or it was said, that you don't even think now to send a rover without cameras, because this is the first thing. You need to know where you are, you need to drive, so you need picture cameras that tells you about the surface. But myself and many other radarists, we say, people doing radar for planetary science, had been advocating for years now that, okay, surface is fine, but if you need to understand, you need to know what is beneath. And okay, it's done. Now that any rover going to Mars or to the Moon now are carrying radar, subsurface radar, that tells them more than surface. There is also subsurface. And we are working to try and build the whole picture between surface and surface to map the context in 3D. And that tells you more about where you collected the sample, where you are, about recent geological history of the place. Okay, and if I can react to you, I was very happy you showed put a cap picture that they were being being built like a jigsaw puzzle, more or less, and also a picture from Minor 4, the one I showed, the first. Yes. It was funny because there are many references, but these are references that people, when they think about Mars and Mars exploration, the first image we get from Mars is, you don't have the detail you have now, but it was really, I think I wasn't there, but it was really interesting stuff.
Yeah, actually, were you aware of that? I wasn't aware of that research that had been done before, like a year only before, where, you know, they had first time like such a good visibility that they could actually, you know, kind of with quite certainty say that there cannot be life on the surface of Mars, and then like just within some kilometers,
yes,
the next year, you know, they print the first picture. It's kind of crazy. But,
yeah, I have a question about perception and how you, as a radarist or
okay,
whatever,
radarist, because I'm dealing with well, radar sounding, yes, but,
instruments,
whatever you want.
Instruments performing, I mean, getting information below the surface, so that is below what the human eye can perceive. And I have this feeling that all the instruments on Mars are, on one side, augmented perception for the human, and at the same time, diminished perception. So how, because what you said, the geologist is on the field, is doing field research. So how do you deal as a scientist between this field research, where you're not physically there, with an augmented perception through your instruments, and the diminished perception because you are far away and you have this delay in getting the information?
Yes, I think that because you mentioned that I'm dealing with what is beneath the surface. Anyway, whether I'm on Earth, on the Moon, on Mars, on Churyumov-Gerasimenko nucleus, I don't have access easily to that. Anyway, if you map the subsurface, I didn't have time to show you the picture we provide from subsurface sounding. This requires a lot of interpretation and even more than images you are used to from the surface. But anyway, they can tell you whether you have got layering, whether you have got slope beneath the surface, what the thickness of the regolith is, kind of sand, dust, layer on Mars, and this is interesting. But anyway, when we are on field test, most of the time we don't know what is beneath. And geologists sometimes use this kind of radar, which is done for Earth. But, so we don't know. So most of the time we will try and dig and check that at least on the top few centimeters, what we interpret, our interpretation is correct by digging and checking. On ExoMars, there will be a drill, 2-meter drill, so we are not going to drill each meter. But on the location where there is a drill, this is going to be a huge challenge for us, because we are supposed to say, before we drill, what kind of layer we are going to find, and then they will check. And hopefully, we would have guessed correctly, but if not, the idea is to use the drill information to correct our interpretation so that we can use it in other locations so that we don't say wrong things. But yeah, for me, radar is anyway, whether I'm here or on Mars or whatever, wherever, it's a reality that I don't have access to by my eyes, whatever. Camera, it's something different. Even if you cannot zoom in with your eyes a little bit, but you cannot go to detail, the kind of detail you say you have access to with a close-up instrument. But we are used to see picture and landscape, and we are so used that if we look at the front, we focus on the front, and if we look too close, we focus too close, and while you look at your hand, what you see in the back is blurred. And this is something, because unfocused, and this is something we are so used to change distance that, but when you have a camera, you need to tell the camera, look close, and that far away. Or when you take pictures, this is the way it goes. And, but we are used to see. So I suspect that cameras imaging, even if they are difficult to understand correctly, because they are missed part, you don't see in the shadow, or because they're just behind a rock, you don't know what is there. But subsurface is an intriguing part, I would say. Even if I'm working for that, on that, I'm still amazed. Sometimes we don't see anything. Sometimes we see very nice features. And chemical analysis, for example, is something, yes, you can taste, you can smell. This is kind of chemical analysis we are used to do in normal way. But these instruments do a better job. I mean, so, yeah.
It's not a very profound question, but I saw on your movie that people were wearing like a bracelet when they were working. It was static electricity, or?
Yeah, exactly. Like with the rover, they have to make sure that there's no electricity, transferred, and they have that rover that you saw. It's an exact copy of the rover on Mars. So they made two. One is there, and they can do all kinds of tests with it, and they also use it like before they send up the real rover, which is built in a kind of a clinic's clean space, and then this one is used also during to do all kinds of. If there's something wrong with the rover up on the Mars, they can also use this one to simulate situations, and it's called the Mars Yard, the place that you saw. So they do all kinds of testing in there. Also with the newest rover, there's now a copy of that in that same place. So.
And I have another question, quick. You emphasize the fact that the working condition with this hazmat suit or protection suit and gloves, and in order to not pollute or contaminate any device. It seems hard conditions, and do you know? And you work for a governmental agency, or and it's not private.
No, it's not. It's not.
And my question is, do people who are building devices to get to the space, like, I don't know, this Elon Musk, for instance, with this satellite he sent, or any other private in the sector, do they have this inspection like the COPRA or SCOPRA?
COSPA.
This COSPA, this COSPA
regulation or whatever.
Yeah, and inspection, or
when we speak about Mars or whatever could be considered as a habitable world, this is the same for Europa, for example, which is a frozen, icy moon, as we say, further away in the solar system. Wherever there is potential where there is ice, water ice, and potential for liquid water, the conditions are very stringent. When you go to the moon, for example, we have already sent people there. They brought back something like more than 300 kilograms of rocks from the moon, And basically, we never found any traces of life. So it's almost admitted by everybody that there's no life on the moon. So people don't really care about protecting the moon from any contamination coming from Earth. But Mars is a hot topic. So I believe this should be the rule. I hope that everybody is going to stand by the rules. ESA is, NASA is, Roscosmos is, I hope China is, because they are on Mars. The problem is with something that was not meant to land on Mars and fall by any kind of accident, and it's not sterilized enough. But we expect that the cruise, anyway, is going to sterilize a lot the platform.
Thank you for the beautiful film. It was the second time I was watching it, and I still really enjoyed it. So thank you very much. Thank you for your presentation too. I also enjoy your presentation, and I have a question. So I'm from the field of media studies, or I'm a media scholar. So I'm really interested, of course, in the bodies that we send to space, but also in the technology that we use. So I'm curious, when you speak about this COSPAR or the people you interviewed, it's clear that these rovers or these technologies, they don't go back to the planetary as compost, right? So what are we speak about the regulations in terms of biohazard or things like that, but what about, where do you situate yourself in relationship to like ecological responsibility, right? Because, you know, maybe space debris are the biggest gifts that we gave to the cosmos. So, you know, like, I'm just curious, what is the place of the environment in the question? So in the space sector, there's an emerging field called space archaeology, which looks at the space debris or everything that was left on the moon or all the rovers and stuff. So I'm just curious, what is the place of the future of ecological development within these practices?
To be honest, there are lots of artificial satellite around the Earth for obvious reasons. Everybody wants to have internet and whatever, so, and television and broadcasting, so everybody is ready to, most people are fine with that. There is an issue with Starlink because they just pollute enough that observation of the sky is becoming sometime a bit difficult, but I think they have accepted to at least change so that it would not reflect the sun's light and make the observation and moon and stars again possible. When we go to Mars, for example, you're right, we are not going to bring back our rover any soon. And this is not a plan. But if you consider the moon, Mars is something like his diameter is half diameter of the Earth, and we left there 10 stuff which are.
It's not a matter of number. It's just to let even one them.
Yeah. I would say that, no, you're right, this is not, but if you are to send them back on Earth, it's going to cost not only money, but energy, and I think the ecological price might be much higher for Earth at least. So I don't know, but I'm biased because, I'm biased because I think that knowledge is above not anything, but I'm still comfortable, maybe we are going to kill me, but I'm still comfortable by leaving some metal pieces on Mars if it is to try and understand whether life started on Mars, and even understand how it started on Earth. So this is my point of view. I understand people might not share it, but
No, this is an answer.
this is, I think that, I think that knowledge, I put knowledge above.
I can just, comment on that because
of course.
That was when I was interviewing the people at JPL, and I just got the sense that it was very, as I mentioned in my presentation, also that it's very science driven, and everything is relative. So you there are also many ways to approach space. So you also have the what I would kind of maybe call like something like the muscle approach. It's like we go there, we do things because we can, and we show things, and and that's just kind of the opposite to the science approach, where you're driven by an interest not to expand yourself, but I mean we were just talking here about the photographs of the black holes. And that kind of research, it's kind of, you can also have a scientist being in the same way interested in Mars, not because of the, idea that of Mars as a possible place for us, but just as a scientific interest. So we can never go to these black holes, but you have many scientists who are very interested in them, and also building very expensive telescopes too. So they are driven by something else than this kind of narratives of, but also there are many things can at the same. I mean there's no line between. So there is a lot of collaboration between the capital and the and the so you have companies and collaborating. But also I think that these governmental institutions, because of the political situation lately with a lot of cuts to universities and science in general, so you have a lot of money pouring into the private sector by outsourcing a lot of things that NASA maybe otherwise would have done, or something which is now done by. So they have probably a lot of pressure on them also to work with these corporations.
I would like to add something. I don't know whether you are aware of that, but when you go to Mars, for example, or to whatever, I think if you have heard, if you remember about the Rosetta mission that travel, the orbiter traveled for 10 years before it could reach the nucleus of Churyumov of Gerasimenko. You need to understand that to leave Earth you need a lot of energy, but afterwards there are almost no engine. It's all done by gravitational. Everything is done that you got assistance, gravitational assistance of planets. You go nearby, so that your trajectory is changed, so that in the end you can reach a point you want. It's a travel. You don't have an engine that is because you would have enough fuel anyway. But
I guess part of my motivation by asking the question is there is an historian of science named Peter Anker who wrote a paper called the Ecological Colonization of Space, looking at the fact that the ecological concerns in the space cabin kind of gave rise to a series of technologies like recycling, bio-toilets, solar panels, and so on, were kind of invented for survival there. So perhaps I was hoping to hear that in the space sector there were some initiatives that were working towards creating technology that would be more environmental, that would be more attuned to the environment. So it was more the idea that perhaps they would decompose in a more ethical way or something. I'm not interested in bringing energy back, but myself, the way I see it perhaps is that Bernard Foin told me that when you send a rover to Mars, you cannot own a space on the moon, for instance, but if you have an artifact there, you kind of own the space around it. So myself, I'm a little bit scared that, in the long run, if SpaceX continues to send stuff like that, they will end up owning a space on the moon or on Mars. So for me, this is quite, it's not just ecological, it's also much more complicated in terms of colonization and stuff. So I was, this was my question.
Yeah, okay.
Well, I could just comment a little bit on that, because some of the discussions I was having with some researchers around this was, kind of questioning a little bit this whole, that we are kind of living in a little bit of a fantasy with these. There are real real companies that are working on one in Luxembourg, I think, which is, you know, envisioning space mining and things like that. And
high space, maybe?
Yeah, I think so. And so, but there is, you know, maybe we are a little bit kind of living in illusion, because I think a lot of people also, you know, usually business is about making profit, and there's at the moment like no way to actually bring back like that amount that you would actually make any profit of it. So it's very much an imaginary at the moment, but it's kind of scary imaginary, this idea that, you know, we go places and we mine there, and also how we approach. There should be like a much bigger discussion about it. Like now it's really like a wild area where everyone is doing like anything they want, because it's that, yeah.
I've got another question about the whole theme of the day was body, and I wanted to ask both of you, and especially you also, Valérie, this is a collective body which is working on those research and rover, and it's a collection of drivers, it's a collection of engineers, it's a collection of scientists of various kinds, and you have to share the available time and life of a rover between scientists, and you have to define, I mean, you have to fight for your time to use your instruments for this or that. So I would like, and in the media, it's curiosity has discovered whatever. So it's very, the fact that it's anthropomorphizing the rover is not the issue, but everything is packed, coalescent into the rover, and all the people behind are left in the dark. And I would like you to reflect about what does it mean when you're a scientist to work with all those teams, and collectively, and inhabiting, so to speak, one single body, the body of a rover.
Yeah, but there are several teams. The team I'm very deeply conscious of is a team of my instrument. Because we have been working together for now, we have been selected in 2003 to go to Mars, and then the mission was delayed several times. So it has been long work. So there are engineers, and there is, I don't know, I think who work on my radar at my lab, there have been 10 engineers, not full-time, but that participated, and almost the same in Germany, because they're working on the antenna. The science team is something like international. There are maybe 20 people, more or less, working on wisdom for the science team. But these guys are waiting. They want the data. Before they get data, there's not much I can do. So, so it's a bit difficult to keep them focused and motivated because of the delay. So, but anyway, this is the team I am responsible for. So maybe there are a few tenths of person, and then there's the team on the rover that I think it's. My point of view is that this is an. We are doing the exploration together, and we need to share time. And it's very funny because we are rehearsing now, try to get ready. And we did a simulation recently, and obviously who gets most of the time very easily are the cameras. Because I say, okay, there is a rock, I want to go close, have a close look at the rock, and then, okay. And I say, can I look beneath the surface? And most of the time, now I think that they have understood, but they say, what are you going to see? I don't know. If you don't know, we don't want to waste time. I say, okay, just imagine you have your camera. There is no light in the room, and I ask you to take a picture. What are you going to see? Don't know. So if you are lucky, you will have some faces. But if you are not, you are going to take a picture of the floor. And so they say, okay, so this is a camera that had no light. Yes, that's it. So we don't know, it's blind. We sound while the rover is roving, and we will see after if there's something interesting or not. The purpose is to discover, reveal something which is not obvious. But you're right, that share the time is a tough discussion, because everybody is convinced that his own instrument is going to bring a little bit more information than the other. While we are all aware we need to work together. But this is, and I would say for ExoMars, we have not really embodied Rosalind Franklin because we are not on Mars yet. We have the ground test model with a Mars yard in Torino, and we are doing some rehearsal, but I think once we are on Mars, it's going to change. But for the moment, I think people, their own instrument first. But we are aware we have started to do simulation together, so I think it's going to be fun. But it's really fun to work with people that are biologists, guys who do chemistry, mineralogy, radar, optical instrument, and so it's very fun because we have different point of view, and altogether we should manage to have a nice idea of what is there.
And Minna, what is your take on this? Because in film, it's also a teamwork. So how do you relate to this?
Well, yeah, it's definitely, that's the great part, I think. That's why I want to do it, because it's, well, I use the word spectral because, what I wanted to do with the film was, to bring in all these points of views so that the theme itself would somehow become more kind of three-dimensional. That's what most documentaries are about. Bringing in like, oh, but then again, and then again, and then again. So in the end, what you thought about something is like, much more complex than what it is really. But it was also, yeah, when I went there, I had a very two-dimensional picture of what this is. So it's, both, it's all these instruments that are being used. So not just cameras, but all the other ones. But then also, actually, when I talked to Vandy the first time, we met in New York, like 2014 in the summer, and I was just going to do we were just going to quickly talk about what her work is like. So I had some kind of idea because I had just seen her. Yeah, usually people ask like, how did you get into this? And so I actually met the head, like the main person of the film in Carnegie Mellon when we studied there in '98. It's a really long time ago, and then she did a PhD there, and then NASA handpicked her immediately. She's like extremely brilliant, but I had always seen her with her Linux computers, and I know that they're working on like what they do as a rover driver, and also in robotics is that they write commands and they write software and things like that. So I thought it was like her work is what I've seen her doing. So then when I came there and I saw it's like all these photographs and like everything is like so I understood it was different. But also what I didn't know is that her days are filled with these meetings. So it's these meetings that they don't get to just say like, oh, one or two rover drivers go like, yeah, let's now drive 1 meter to the right here. Okay, we'll send it up. No, it has to go through so many different, because this is like a $1 or $2 billion machine. So, I mean, it's not just monetary value, but it's
not the machine, but the work stuff.
Exactly.
Launch included.
And a being, and they. So I mean, there's many reasons why it has to be double and triple, checked But they also, so there are all these people, but then the scientists come into the picture, which is nothing is done without a science goal. So do you have people from all over the world? So there's this complexity on all levels of this machine. Also, how they make the machine first. So it's several people. I talked to the PI of the camera, Jim Bell. His name is from the University of Arizona, and he gave a long interview, and he was saying that even the camera, like the mast cam, which is now also on the newest rover, even that is a system he doesn't completely understand. even though he is the principal investigator of the project and been through everything and knows photography, knows geology, knows everything, and so each little part is its own robotic system, which has its own artificial intelligence, and that complexity, when you start looking at that rover, it's incredible. We can actually send something like that and it works, but still the hardest part has always been the landing itself. So we also talked about that, but then so what Janet is also writing about and talking about is that the pictures and the photographs also play a role in communicating with the scientists, so that you have something to look at when you tell something, try to communicate to each other. So yeah, that was very interesting to understand the complexity of it all in terms of communication as well.
I just wanted to add something. This part, when the participants in your movie, in your film, are talking about how they have to change the colors, the shades, and everything to interpret, is super interesting. And it reminded me of a paper by Peter Gallison, who was quoted by a participant of your film, and it's in his book. Picturing Science Producing Art, or the contrary, I don't remember now. And it's about Galileo, and he explains, or he states, that Galileo was the first to understand that the moon has craters, not because he had the best telescope, but he was trained in painting. And so he could interpret the shadows.
That's really interesting.
Oui, il y a une question là-haut.
First of all, thank you. I'm actually studying a PhD in the how's it called? The iconography of space, and so it was really, really refreshing to hear this embodied narrative and intervention that you have, because about changing the color, and there's a really good book that is called Picturing the Cosmos by Elizabeth Kessler, which is really old, but is still actual today, into showing that the images that were given to see their actual interpretation, and it's still a lot about pioneering, going, conquest. So it was really interesting to see that how the body is there, not just a vision, because vision is really capitalistic driven, as we know. And so to come to what Valérie was saying, is there some hope that being a body of knowledge that goes there, that watch there, but there's a physical object that goes there, and so they can get physical samples, more than just data that are translated into pictures, and then the translation is all the political thing, of course, but not going to go into that. Is there some hope that we're going to have a more informed picture? Is it interesting for the communication after that all the information that comes from different fields of knowledge blend together to give a more informed image?
I'm going to, I'm not sure I understood your question. So let you say that given the fact that we will have sample back on Earth, we are going to be able to give a better interpretation and picture of picture we take on Mars because of this sample, more or less?
No, yes and no. More than we're sending, as if we're sending different kind of knowledge. More people from different fields are going to analyze, because there's one object that is there that everybody's sharing. So the reading afterwards, is there going to be more layers from different fields that actually interlace, and more than just one political translation that was given, for example, by the NASA when the telescope was looking at this and saying, this is blue, this is green.
No, this is always the way, sample or not sample back from to Earth. This is always how it goes in science. I mean, you can, at least, maybe in my field, let's say, people get data, and basically what's going to happen, I suspect that the first data I get from my radar, by the way, wisdom is, say, sagesse in French, because the idea was to be that it was wise to know where to drill before actually drill, and this is an acronym we worked a lot which is a water ice deposit observation on Mars. So it's a nice icon. Anyway, about this radar, when the first data come, you have got few tenths of minute to give a rough interpretation that you discuss very rapidly with the other PI of the instrument so that we get an idea where we are, what we do, and what is next step. But when it comes to publication or public outreach, most of the time the first publication or dissemination to public is a rather crude interpretation because we don't know. Say, okay, this is a picture of the subsurface of Mars nearby the landing site. We can see that there's something, there are layers, they are tilted, and so like that. And you need to do that rapidly because people expect you to give some information very rapidly. And then you have got months, years, to make sure that what you see is exactly, and you make, you need to be consistent with what you see from the surface to make sure that your interpretation is consistent with what is at the surface. And then if you want to have interpretation about, then you need to know for the other instrument, say, okay, what kind of material do you think, what kind of rock do you think it is? If it is clay, what kind of time it would have taken on Mars to have this thickness of layer? And this is not something you can decide and understand by yourself. You need the other instrument. So I think it goes from most plain information with that nobody can fully understood, but just to show, okay, we spend time, money to build a mission, there are instruments, they are working. And you can tell already something very roughly about what we saw. And then you have works for months, years. And that, Rosetta stopped maybe already, it's not 10 years ago, but 7 years ago. There are already still paper coming out that process the data, interpretation of the data. Because you model, you model the geological evolution of the landing site. So when your model is, your model is fed with the information we get, and you need this kind of a loop, you know, virtuous circle you put inside, and then it hopefully converge with the reality. But this is a very interesting process, but it takes time, a lot of time.
Bien. I'm going to switch back to French. Almost. Well, I thank Minna and Valérie for their talk, and now I'm going to switch to French.
Thank you very much, both of you.